And in this video, I'll be talking about the company background. So the company that we chose for this project is FoodPanda Malaysia from Delivery Hero Malaysia Sendirian Berhad. Industry is in e-commerce, logistics and on-demand food delivery. It is a part of Delivery Hero headquartered in Berlin and operating in Malaysia since 2012. Also acted as a digital bridge between customers, riders and also vendors. So next we are going to talk about core products and target customers. For grocery delivery via PandaMart, they usually targeted young professionals and families. But for quick commerce services like Panda Now, they usually target customers prioritizing convenience and fast deliveries. Scale and marketplace model. First, it operates locally and globally under a Delivery Hero. It also has strong nationwide presence across Malaysia. It has three-sided marketplace. First, customers, riders, and vendors. 4. It is big data essential to balance demand, supply, and profitability.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Zaki Izzat bin Osman. Matric number CE220075. Okay, today I want to present about the big data use case overview. Big data is the core driver of FoodPanda operation. And next, focus on marketplace balance. They have key objective. For the first key is match rider supply with customer demand, and the second key is reduce operational cost, and the last key objective is improve customer satisfaction. For the case 1, demand supply equilibrium. For the first, predict customer demand accurately, and the second, optimize rider incentive and availability, and the third, avoid issues such as high demand with insufficient rider, and next, excess rider leading to waste incentive cost, and the last, support revenue growth and rider satisfaction. Okay, move to the case 2, real-time logistic and route optimization. First, process 100,000 plus GPS update per second. Second, use big data analytic to optimize delivery routes dynamically and stack multiple orders per rider. And third, provide accurate ETA to customers. And the last, result in lower cost per order. And the case 3, personalization and churn prediction. For the first, predict customer demand accurately, and second, optimize rider incentive and availability, and the third, avoid issues such as high demand with insufficient riders, and second, excess rider leading to waste incentive cost, and the last, support revenue growth and rider satisfaction. Okay, move to the next slide. For this slide, I want to share about big data platform and architecture. Point first is build on a serverless operational data lake. Second, powered mainly by Amazon Web Service, short form AWS. And the third, design. For design, have two elaboration. For the first, design for high data velocity, and the second is scalability. I think that's all from me. Thank you.
Hello, Assalamualaikum. My name is Muhammad Izan bin Murtaza, matric number CE220088. I will briefly explain FoodPanda Malaysia data pipeline, which consists of ingestion, storage and processing. First, in the ingestion layer, real-time data such as rider, GPS location and order event are captured using Amazon Kinesis. At the same time, data from third-party system is integrated using AWS Airflow, while operational database are synchronized through AWS database migration service. Next, all collected data is stored in a centralized data lake using Amazon S3. The data lake is organized into different zones, including raw, clean, transform, and curate data. This structure help maintain data quality and make analytics more efficient. Finally, data is processed using AWS Glue, which perform ETL tasks such as cleaning and transforming the data. AWS step functions are used to manage the workflow and ensure reliable execution. For big data processing, Apache Spark through AWS Glue is used to handle large dataset, while Amazon Kinesis manage real-time streaming data. Amazon S3 acts as the main data lake. DynamoDB support fast NoSQL operation, and Amazon Redshift is used for complex analytical queries. For analytic and visualization, Amazon Athena, Amazon QuickSight, and Tableau are used to generate insight and dashboard. Lastly, Amazon SageMaker support machine learning tasks such as demand forecasting and customer churn predictions. So for infrastructure, FoodPanda use a fully cloud-native infrastructure on AWS. Firstly, scalability. Serverless service like S3, Kinesis, and Glue automatically scale during peak period, such as lunch and dinner time, or during bad weather. Secondly, about fault tolerance, the system is deployed across multiple AWS availability zones, ensuring continuous operation even if one zone fails. So thirdly, about cost efficiency, which AWS pay as you go model, FoodPanda only pay for the resources it uses, making the system cost efficient and flexible. Overall, this big data infrastructure allow FoodPanda Malaysia to operate efficiently, scale seamlessly, and make real-time data-driven decisions. Thank you.
Hello, my name is Halimatul Saadia binti Ahmad. My metric number is CE220090. I will present about data management and processing. For data management and pre-processing, FoodPanda Malaysia places strong emphasis on maintaining data quality as it directly affects system performance and decision accuracy. Firstly, data cleaning is handled through automated ETL process using AWS Glue. These processes detect and correct issues such as corrupted order IDs, duplicate records, or inaccurate GPS coordinates from riders. This ensures that only valid and reliable data is used for analysis. Secondly, for handling missing data, FoodPanda applies techniques such as statistical imputation and historical averaging. For example, when real-time rider locate data is temporarily unavailable, historical movement patterns are used to estimate the missing value. This prevents disruption in logistics and delivery optimization models. Lastly, integration is achieved through a centralized data lake architecture. The system seamlessly combines structured data like transaction record, semi-structured logs, and unstructured customer feedback. This integration provides a comprehensive 360-degree view of operation, enabling more accurate analytics and business insight. Next, we move on to benefits and challenges. The implementation of big data analytics has brought significant benefits to FoodPanda Malaysia. One major benefit is improved operational efficiency. By optimizing delivery routes and stacking multiple orders for rider, the company is able to significantly reduce the cost per order. Another benefit is strategic business growth. Data-driven insights allow FoodPanda to allocate rider incentives and marketing budget more effectively, which directly contribute to higher gross merchandise value. Additionally, customers enjoy a superior user experience, including faster delivery times, accurate estimate arrival times, and personalized food recommendations. However, there are also several challenges. One key challenge is managing high data velocity and low latency requirements, as the system processes over 100,000 GPS updates per second in real time. External factors such as weather condition and competitive promotion can also reduce the accuracy of demand forecast models. Finally, maintaining such a complex cloud-native architecture requires highly skilled data engineers, making talent acquisition and system maintenance a continuous challenge. Lastly, ethics, security, recommendation, and conclusion. As FoodPanda handles large volume of personal and location data, ethical, security, and privacy considerations are critical. In terms of legal compliance, FoodPanda Malaysia must adhere to the Personal Data Protection Act or PDPA 2010. This includes obtaining explicit user consent for data collection, especially for sensitive information such as geolocation data. The company also needs to prepare for upcoming PDPA reforms that strengthen user data rights. For security measurement, FoodPanda employs a multi-layered approach. Sensitive data is encrypted both at rest and during transmission using AWS Key Management Service. Access control is strictly managed through AWS Identity and Access Management, following the principle of least privilege to ensure that only authorized personnel can access customer data. From an ethical perspective, algorithmic bias is a major concern. Delivery assignment algorithm must be continuously monitored to avoid unfair treatment of certain riders or customer location. Transparency is also essential, particularly in explaining how data is used for pricing, delivery fees, and estimate delivery time. In conclusion, big data is the foundation of FoodPanda Malaysia's operational and strategic success. Through the use of sophisticated AWS-based data lake and advanced machine learning models, FoodPanda is able to effectively manage a complex three-site marketplace involving customer, riders, and vendors. This big data-driven approach has resulted in improved operational efficiency, enhanced customer satisfaction, and sustainable business growth, positioning FoodPanda as the leader in the on-demand delivery industry. Based on this case study, several recommendations can be proposed. Firstly, FoodPanda should develop hyperlocal demand forecasting model that incorporate localized events such as community festival, traffic incident, or weather condition. This would improve rider deployment accuracy and reduce operation inefficiency. Secondly, the integration of generative AI into customer support service should be explored. This will enhance response efficiency and better handle multilingual communication, which is especially important in the Malaysian context. Finally, FoodPanda should expand its use of sustainability analytics by tracking and optimizing delivery routes to reduce carbon emission. The company can align its operation with global ESG goals and strengthen its corporate social responsibility efforts. That's all from us. Group 4, thank you very much.